The Databricks is the programming based data integration software. I think we all of us know that. Okay. And it has got the Databricks Spark cluster. That's where the actual code is executed. This is the distributed computing based software cluster, Spark cluster. So the Databricks originally developed on the Scala programming language. That is the extension of the Java. Java is the object-oriented programming language. Scala is the functional programming language. It's developed on top of the Java. We do not need to go too much internals on top of that. But we need to aware that the entire Spark cluster and the Spark code and the Spark libraries are developed on the Scala programming language. Java and Scala is widely used, but in the data processing, they mainly using Python. Okay, Python is everywhere. In all of the data analytical platforms, they are using it. So they have developed a abstract layer. Abstract means a virtual layer on top of that Scala programming language. And they have given Python libraries for us to use in the Databricks. That's what we call it as Pyspark. We write the code in Python and that internally converted into the Scala programming language, and it will be executed in the Apache Spark cluster. That's what happened internally. But Pyspark is one of the abstraction layer. They call it as APIs. They have provided to us application programming interface. On top of Pyspark, now they have also given the another engine called SQL engine. Even you can write a code in SQL, and that will be internally converted by the Spark software, and it will be converted to the Scala code and it will be executed. But we do not need to worry about that much. So whenever, so the Apache Spark itself is a software package. Okay, it has got set of functions, set of classes, and set of libraries, and it's packaged thing. To access that Spark cluster, we have got a thing called, there are two things, it's both are same. Okay, we have got the thing called Spark or Spark context. Okay, that is the entry point for accessing the Spark cluster. Any programming you are going to write it on top of the Databricks, you need to use in the first instance Spark or SC. Okay, that is the default instance it got created. You can compare this with the main section in the Java programming language or C programming language. That is where our code is going to be executed. That is the entry point. So now the data can exist inside the Azure cloud. We have got that scenario. One of the scenario is we already brought the daily pricing files into our landing layer, and inside the landing layer our daily pricing files are existing. That means this data is existing inside the Azure cloud for the time being. We ingested using the ADF, that is the different part. But as of now, if you consider the data is already present inside the Azure, then we can directly access this data inside the Spark. We have tried that one as well last week or a week before. We have created one quick notebook to ingest the daily pricing data existing inside landing layer into our data lake house. Okay, I think I need to go back a little bit behind here. When we created the data lake storage account, we used the ADF to load the data into landing, and we also used the ADF to build the pricing data lake inside the ADLS2. That is specific to data lake house terminologies. Okay, logically we separated the data for landing and the data lake. Now we are exploring the Databricks. I need to have separate logical container for that one. That's why I created the data lake house. This follows the medallion architecture. That's what we are calling in Databricks to build the data lake house. And here we call three layers: bronze layer, silver layer, and gold layer. We have not yet built silver layer and gold layer. In the bronze layer, we always will have the raw data. In this instance, our first data is existing in the same data lake storage account, landing layer, because this is also possible. Okay, some instances when you are starting the Databricks coding, The source data may be present in the ADLS. If it's not even present in the ADLS, we can bring it into the ADLS. That is the second part that we have seen last week as well. So our source data at the moment existing in ADLS landing layer. I am building my data lake house. Inside my data lake house, I am going to have 3 layers, bronze layer and silver layer and gold layer. I am bringing this data in the CSV format into the Parquet format in the bronze layer. That is the first notebook that we have developed. Couple of the comments here for supporting and browsing the data lake storage folders. How many folders are there? We call that as a Databricks utilities. The first 3 comments are not making any specific significance here. It's just connecting to data lake storage account and browsing the folders in the data lake storage account. This is the code we have written. This is where the Pyspark we started to write it. So the Pyspark is built on top of the Scala original Apache's code set. The Pyspark includes set of libraries. On top of that, this is again Python environment. You can use all of the standard Python code as well here, because we are executing we are calling it as Pyspark, but it also includes the Python compiler as well, standard Python compiler as well. So when doing the coding, you need to differentiate where we need to use the Python code, where we are using the Pyspark code, and how these things are interacting it. When we need to start to use Python, general Python, when we need to use the Pyspark. Whenever we are referring the Spark, that is the entry point I am talking about. This, whenever a code involves with the Spark, here and hereafter, any variable that we used to assign the output of the Spark, that all become the Pyspark code. Okay, and that will be the one of the reference I can give. In some exceptions will be there, we will see it. And apart from this, the standard Python code also here used. For example, I am assigning my source daily pricing folder into one of the Python variable. There is no Pyspark code here. It's the standard Python variable declaration. That is the difference we need to know. So now our source data is existing in the files. With respect to data factory also, you can refer these source data or any data that we are producing it, either source data or the target data that we are producing it. If we are referring it as a data set, probably data set may be little confusing here. We can call it as source data or target data when referring the physical files. When if you come inside the Pyspark, okay, the reference for each of your data, it can be a source, it can be a sink. It is called a data frame. Okay, that is the keyword that you are using inside the Pyspark, specifically Pyspark. When you write the Pyspark code to read your source file or to write your transformed data, everything referenced as a data frame. Data frame is just a pointer inside the Pyspark code to represent your data. Okay, that's the one thing you need to be aware of it. So there are 3 things are there. One is RDD, another one is data set, another one is data frame. Okay, these 3 keywords that we are using in the Pyspark. Okay, for example, when all 3 things can be used still inside the Pyspark. Okay, for example, if I use RDD is basically resilient distributed data set. Any data that you are processing inside the Apache Spark, that is the lowest level of the presentation of the data inside the Apache Spark. So if you are reading this file using the RDD, we know that this file has got the header, but inside the RDD, these column names are not internally inferred. Okay, you need to specifically mention that when trying to read the CSV file via RDD Pyspark libraries, then you need to mention that my first column is this column, my second column is this column name. You need to change it. So that is looking very low level coding. Okay, when you are reading your file and you are defining your column names, then you are defining your data types, then you are doing operation on top of the data set. So the Spark, they have developed another one abstract layer on top of the RDD that is called data frame. So data frame, inside this data frame, if you say that header is true, it will automatically infer the first row as a column names by default. Okay, so that is giving easiest programming interface. At the end of the day, either you write a code on RDD or you are writing the code on the data frame, the execution engine is going to be same. Even we write it in the data frame, when the code will run, the Apache Spark internally converts that into the RDD, because RDD is the one, the physically the data will be split and executed in the cluster. That never changes. Okay, RDD never changes actually. RDD is, so it will convert it. So these data frames are giving very flexible way of us writing the code and manipulating the columns in our data set and converting that columns into the different data types, or merging the couple of columns together and creating the new columns. These type of the operations are the one we are using in the data processing. So these data frames are the one helping us to write the code in the easiest possible way. The same code can be written on top of the RDD as well, but in RDD we will write one line of code in the data frame. Probably it will be more than one line of the code in the RDD. It will be too difficult for any data process professionals. That's why they have developed the data frame. Now they not only data frame is there is a SQL as well introduced. In SQL, the data frame and the SQL table are almost same. Okay, except some operations that we are doing it on top of this data frame is different. In the table you are writing the SQL statements. For the data frame you are using the Pyspark API functions to process your data.